Ayan. So, hello, dears. Hello, hello. Yes, good day. Hello. Kamusta kayo dyan? Hello. Ayan. So, again, hello, dears. So, welcome to yet again another pre-recorded lecture in our class in parasitology. No? And for this lecture, you may be wondering, sir, lahi lagi ni siya or like bago lagi ni siya. Like, why is this a new way of of lecturing? Yes. So, for now, no, for this topic, I'm just going to use Loom para mas makita ninyo, all right, so that you'll see better the things that are found in the PowerPoint, no? So para din naman, no, you don't get to see me that much para, you'll miss me din naman. Char. Okay, drama. All right. Ayan, again, so for this lecture, we're going to talk about the calibration of the ocular micrometer. Again, one of the important stuff to know in our class in parasitology. All right? Okay, ayan. So medyo may mga math dito konti. So medyo simple naman. So I hope maka-catch up lang. Okay. All right. Ayan, now we go now to the introduction. So what is micrometry? By the name itself, micrometry is a science of measuring objects under the microscope. Yes. Because again, there are organisms or there are things that need to be measured under the microscope. Now, of course, we cannot measure them using our normal ruler or like other measuring devices because again these things that we measure under the microscope are microscopic or they are not visible under the naked eye. That is why if we want to measure no things under the microscope, we then employ the principles of micrometry. Okay, all right. And size in our class in parasitology, no, size matters. Okay. All right. How about you guys? No, does size matter or performance? Size or performance? Charot lang. All right. So again, in measuring parasites, no, size is of one of the major things to consider. But if you want to perform rough estimation, only rough, oh, ay, gusto nyo ba yung mga rough? Joke lang. So rough estimation lang of the size of the parasites. You can compare with the RBCs. But then again, that's not accurate. No, that's only a rough estimate. Okay, so you're not determining the real sizes of your parasite. Okay, so if you want to measure accurately your parasite or your organism, then we then use what we call your ocular micrometer. Okay, that is calibrated using the stage micrometer. Okay, so we'll then discuss why is it important to calibrate, what are these micrometers, etc., etc. But again, the main concept or the main rationale as to why we have this activity or lesson is because, again, measuring parasites, measuring our organisms in parasitology is of an important thing to do. All right. Okay. Ayan. So we'll now go to your micrometers. So again, as mentioned, there are two types of micrometers. You have the ocular and the stage. Okay. Now, when you say ocular micrometers, these are glass discs. Okay, can you imagine? We have a picture later. All right. So it is a glass disc that has a parang ruler inside of it. Okay, and you have 50 to 100 small divisions on the glass disc. Okay, and this glass disc is then put or placed in our eyepiece. Okay, in our ocular eyepiece. That's why it's named as ocular micrometer. So the ocular micrometer is placed in your eyepiece, so therefore it is always stationary. Okay, no matter how many or no matter what objectives you use, the ocular micrometer stays there, so it does not move because again, it's included in the eyepiece. Okay, understand? So again, it's in the eyepiece, the ocular micrometers. I have to emphasize that. By the name itself, ocular. Therefore, it's the micrometer that is placed inside your eyepiece or oculars. All right? Okay. And these divisions, they have different measurement values depending on the power of the microscope objective used. That is why there is a need for calibration. Later, again, I'll explain. Because again, for different objectives, let's say you start with 4x, your scanner, then you go to low power, then you go to 40x. Each of the measurements, no, or each of your ocular micrometers have their specific or corresponding measurements of the divisions. Like how much micrometers are there, how much micrometers are found in each division sa ocular micrometers. Later, you'll understand more when we go now to the pictures. And how do we calibrate? before that, yeah, this is the ocular micrometer. So as you can see, it's a glass disc, and then as you can see, this is now your micrometer, no? So this is the ruler, parang ruler inside of it. Again, this is placed inside your eyepiece. Okay, all right. And again, how is it calibrated? Using a stage micrometer. Now, the stage micrometer has a known measurement. All right, so it has a known measurement that we then base, no, the measurements of our ocular micrometers from. Okay, so it's a calibrated scale of zero point 0.1 millimeter, and then actually it has smaller divisions that is about 0.01 millimeter ang division. All right, and this is the stage micrometer. So as you can see, it's a slide. Okay, it's a slide, and then you have the circle there at the center. This circle contains now somewhat similar like this, but again, the difference is that the measurements, no, of the lines in the stage micrometer are known. Okay, they are known. Like we know that that's zero point 0.1 millimeter. Okay, each division. All right, and we have yeah, again, that's the point. The measurements of the stage micrometer are known. So the main like principle, or like what is the main rationale um of your uh micrometry, no? Let's say we have a known line that's measured 100 meters. Okay? All right. And then we have an unknown line. I sorry. Okay. 100 micrometers. All right? Okay. And then we have a unknown line that is unknown. Okay? And then we have the unknown here, which is again, sorry, the known, which is 100 meters. And then we have the known. All right? And then the unknown line, all right, or the unknown line, yes, is, let's say, three-fourths of the unknown. Okay? Three-fourths. All right? So it means then that we have a known line that is 100 meter. All right? Can you follow? Yes. We have a known line with a measurement of 100 meters. Okay. And then it is now, this unknown line now is compared to the known line with the measurement of 100 meters. And we said that is three-fourths, diba, of the known. Therefore, we can say that the unknown line has a measurement of about 75 meters. Gets? All right. So that's just an example. So that is the main principle, all right, or the rationale behind calibration of the ocular micrometers using stage micrometers. Okay? I hope you understood that. All right. Okay. Ayan. Okay. So we'll now continue. So again, why is there a need for calibration? So I'll present to you two pictures. First is, let's say, an organism at 10x, and this is its appearance in using the ocular micrometer. So as you can see, no, it appears small, all right? And if we measure, okay, if we measure, diba, the organism is 1, 2, okay? Two ocular ocular units. So when you say ocular units, it's one one division, okay, from here up to uh yeah, that's one uh 2. Okay? All right. 1, 2. Okay. That's under 10x. But when we go now to 40x, okay, so we increase the magnification. As you can see, the image or the organism becomes much larger, but actually it just has the same size with this. All right. The difference lang is that it was magnified into a much higher magnification. That is why it appeared bigger. But in reality, the size of this organism to the size here is the same. Gets? So that is why we need to calibrate your ocular micrometer per objective so that we know how much does each of this line measure. All right, so that we can then measure the size or the length, example, of this organism using this magnification, and then also calibrate this ocular micrometer in this magnification to determine again how much it measures, no, one division to the other, so that we can measure this organism using this magnification. Gets? Because again, as you can see, there's no standard in a way, no? There's no, the ocular micrometer, as I've mentioned, is unknown. Okay, you don't know the measurements. Okay, so you cannot say that it's standardized for all of the magnification. That is why we need to calibrate, okay, for each magnification. So if you're using 10x, you need to calibrate. For 40x, you need to calibrate again. Again, using the stage micrometer, which has a known measurement, okay, or measurements. All right. Okay. And of course, it also matters per microscope. So if you use this microscope, this is the calibration for each of the objectives for 4x, 10x, and 40x. All right. And for another microscope, you need to calibrate again. Okay. So um, you cannot carry over the calibration from one microscope to another microscope. So you need to perform new calibrations whenever you use other microscopes. Okay. All right. But again, the main point is that why is there a need for calibration? The units on the ocular micrometer are arbitrary. When you say arbitrary, they are unknown, they are not standardized, or they are not established. Okay? And again, as mentioned, the difference and the distance rather that they measure varies with the different objectives. So hence the need for calibration. Because again, the measurement is not standardized. Okay, the measurement of the ocular micrometer is not standardized per objective, so you need to calibrate per objective. All right. And the distance between ocular divisions, how do we determine? We superimpose, okay? So when you say superimpose in Bisaya, imong sapawan, okay? You superimpose the ocular micrometer with the known stage micrometer, all right? And we then determine the measurements, like if one ocular unit, how much is it equivalent to using the stage micrometer, all right? Okay. And the key concept, as mentioned, the ocular measurement corresponds to different lengths depending on the objective that is being used. Again, I have to emphasize that each objective we have to calibrate. Okay. All right. Depending on the objective, again, that is used. All right, and if you notice, as as we go higher with the objective, the stage micrometer also becomes closer because again, it's much more magnified. Okay, all right. So the ocular micrometer at the end of the day is what we use to measure the organism. Okay, the stage micrometer is just for calibration. Okay, all right, ayan. So again, stage micrometer is only for calibration. Ocular micrometer is what we use for measuring the organism. All right. Okay, now we go na to principle. Again, as mentioned, ocular micrometer. Again, asa siya nakitaan or where is it located? In your eyepiece. So it's inside your oculars, it's inside your eyepiece. Okay, and once it's properly calibrated, it's instrumental for measuring the size of your microorganisms in the microscopic field. And again, as mentioned, the distance between the graduations or the lines of the ocular micrometer is calibrated for each objective lens. So this is the procedure. So you remove your eyepiece, no, you can remove your eyepiece and then you twist and then you then get this, no, all right, and then you then insert your ocular micrometer, all right, by printed surface down. Okay, so the one that has the parang lines, diba, as what was projected in the picture a while ago, no, so that's print down. Okay, and then once you put that, you then put it back inside. All right, so then you can now see the ruler or the line from the ocular micrometer when you view it in the microscope. All right. So again, procedure 10x ocular, and then we place again the ocular micrometer. Okay, then after that, we place a stage micrometer and focus on the same portion of the scale. And then looking through the microscope, examine the ruling of the stage. So again, if there are large lines, that's zero point 0.1, and the smaller ones are 0.01 millimeters. Okay, but again, in parasitology or organisms, we usually measure them in microns, okay, or micrometer. So if we convert this millimeter to micron, you just multiply that by 1,000. Okay? So, zero point 0.1. Sorry guys, ang pangit ng... Ay, joke. Sorry. Wait, ang pangit talaga ng ano ko. Zero point 0.1. Wait. Oh my goodness. Let's say again. Zero point 0.1 micrometer to zero point 0.1 millimeter, sorry. You just multiply this by 1,000, so that's equivalent to multiply by 1,000, so that's equivalent to 1,000 micrometer. Okay. All right, 1,000 micrometer. And of course, this is equivalent to how much? 100 micrometer. Okay. Ayan. All right. Okay. So that's how you convert millimeters to microns. Because again, our organisms, our parasites, usually if you measure them, we use the unit microns or micrometer. Okay? All right. Ayan. Again, what we do now is we adjust the field so that the line 0 on the ocular micrometer is superimposed on the 0 line on the stage micrometer. Or some ocular micrometer kay 100 perpendicular to the to the 2 millimeter line in the stage micrometer. But what we follow is this one, guys. 0 line on the ocular micrometer is superimposed nato siya on the line on the 0 line of the stage micrometer. So here's an example. Ayan. So this is your ocular scale and this is your stage micrometer. So again, the 0 of the ocular micrometer, we then superimpose that here. Okay, 0. All right. Ayan. And again, these are point 0.1. This is point 0.01, the small ones for stage micrometer. Ha. Again, the stage micrometer has the known measurement. Okay, the known distances or the known measurement. We know that the big lines are 0.1 millimeter and these small ones are 0.01. Okay, so 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.2 millimeters. Yeah, tama, millimeters. Okay? And the ocular here, don't be confused with the numbers. Okay? That's still unknown. We don't know how much it measures, how much a millimeter is there. Yes, we don't know. Okay? Because again, as mentioned, the measurements of the ocular scale are unknown. Okay? All right. Ayan. That's why we need to calibrate. All right. So again, we position the 0 of the ocular scale on the same, exactly superimposing on the 0 scale of the stage micrometer. Okay? All right. And then next, what we do is we then look uh, extreme right or extreme left to where two other lines are exactly superimposed. So example, yeah, okay, and count the number of division lines on the ocular micrometer between the 0 lines and superimposed lines. So example, this one, no, superimposed siya, all right? We then look here or to the right and determine what line another two lines are superimposed. So example, this one, number 1, yes, pwede. Or also number 2. Okay? Basta two lines, another set of two lines that are exactly superimposed. Okay? Alright, so this is the stage micrometer na ruler, okay, or the measures. And then this is the ocular. So again, line first the 0 of both the stage micrometer and the ocular micrometer. And then after lining, you then find another set of lines, two lines that are exactly superimposed on each other. Okay, so example, this one, diba? As you can see, this line and the one on stage micrometer, and the number 2 on the stage micrometer, and this also, diba? All right, ayan. And then we count the number of 0.1 m divisions between the 0 line and the second line, and we then determine how much one ocular unit is equivalent to in terms of the millimeters. Ayan. So we now go to yeah, calculate. Ayan. Okay. So example, sige. So we have this example, picture of the ocular micrometer and the stage micrometer. So again, we line it up, no? The 0 of the ocular micrometer on the stage micrometer na 0 then. All right. Okay. And then we then find again another line, two lines that from the stage micrometer, one line from the ocular and one line from the stage micrometer that are exactly, excuse me, superimposed on each other. All right. Ayan. So for this drawing now, there are 33 ocular units. So 30 ocular, ha? 30, 30, 1, 2, 3. Ayan. 33 ocular units is equal to, in the stage micrometer, 0.22. So 0.21, 0.22 millimeters. All right? So para mas ma-clear, ayan, I've drawn a red line. Ayan, so 33 sa 0.22. All right. You know, we can set up a ratio and proportion equation, di ba? Yes, recall in your mathematics, basic math, yes. Okay. So, di ba, 33, okay, ocular units, OU lang, over 0.22 millimeter. Okay, so we're looking for how much is one ocular unit, okay, equivalent to in millimeters, which is x. Okay, so we then cross multiply, di ba? Okay, ayan, therefore, ato ang next equation na is 33 times x is equal to 0.22 millimeters. Okay, and to find x, we then divide everything by 33. All right, and your x therefore is point 006. Sorry guys, hindi siya maklaro. millimeters. Okay, so this is the long version lang. Okay, long way. All right. But again, for a shortcut, we just divide the 0.22 millimeters by 33 ocular units. So the same, as you can see, pwede natong makancel ang ocular units, no? And you're left with millimeters, di ba? Recall. So therefore, 1 ocular unit is equal to, still the same answer, 0.0066 millimeters. But then again, di ba? We usually use micrometers. So we then multiply this value by 1,000. All right, so that's just shortcut ng pag-multiply. You just move the decimal point 3 times 1, 2, 3, 'di ba? Recall. And that's equivalent to 6.6 micrometer. Okay, so therefore, it means then that one, okay, sige. Sorry. Ayan. One of this, di ba? One from 0 to this small line here, that's equivalent to 6.6 micrometer. Okay? And then from this small line na po to the next line, it's equivalent to 6.6 micrometer. Ayan. So right now, so we have calibrated your ocular micrometer. We then know how much of this one line is equivalent to. All right? So we can now then measure our parasites. Okay. So example, here we have a small sample joke. Sorry, continue pa pala. So again, record the calibration for each of the objective. And as mentioned, as I've mentioned, the lines of the stage micrometer will increase. Okay. And the ocular micrometer is still stationary. It will remain the same. All right. Because again, you increase the magnification of the stage, so the stage micrometer, so therefore it becomes much bigger or it becomes much closer. All right. Ayan. And of course, we then remove the stage micrometer if we have calibrated our ocular micrometer already. And then we put now the parasite or the organism that we want to measure. And then we then measure it using the objective. As mentioned, each objectives has their own calibration. All right? Okay, ayan. And then we can prepare a chart that displays the calibration factor like 10x. This is the calibration. Like example, 10x, each of the lines sa ocular micrometer is 6.6 micrometer, like a while ago. If 40x, each of the line in the ocular micrometer is equivalent to, let's say, 20 micrometers, like that. Okay? All right, ayan. So we go now to a sample problem. Ayan. So using the derived measurements a while ago, yung sinolve natin, mga mga gipang answer nato, um, we determine now the length and the width of a Georgia duodenalis cyst, okay, given below. So here's the picture, ayan. So this is the length, and of course, this is the width. Ayan, medyo hindi clear. Again, and this is our working formula. 1 ocular unit is equivalent to 6.6 micrometer, as mentioned a while ago in our previous slides, di ba, atong gisolve. We then count how many lines is the Georgia in terms of length. So we have 1, 2, 3, 4. Joke, sorry. We then, sorry. We then check the divisions pala. Okay. All right. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ayan, dito ang last, diba? So you can see, muna siya ang last. All right. So therefore, the length is 15 ocular units. All right. And since we already know that each ocular unit is equivalent to 6.6 micrometer, so we just multiply, all right? We just multiply 15 ocular units. Ayan, 15 ocular units by the measurement, 6.6 micrometer, that's equivalent to 99 micrometer. All right? Okay, ayan. So I hope na-gets lang. That's for length. All right? And for width, sige nga, can you try by yourself daw? Sige, I'll give you some time or mga a few seconds to solve daw. Sige. All right. Ayan. Okay. Tapos na? Okay. All right. Sige, let's count again for width. How many lines? So, 1, division 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 9 lang? 9 ba? Wait lang. Di medyo klaro eh. So I think, yeah, until here lang. Diba? Ayan. So that's equivalent to 9 ocular units. Okay? So still the same procedure. 9 ocular units times 6.6 is equivalent to, actually, if you multiply this, it's equivalent to 59.4, but we just rounded off to 60. All right, so 60 micrometers. So this Georgia cyst is 99 micrometers in length and 60 micrometers in width. All right. Okay. So basically, guys, that's it. That's our procedure in ocular micrometer, no calibration. It's quite simple, straightforward. So we'll practice on solving problems like this. And yeah, I think this is your second worksheet. But again, emphasize lang, why do we need to calibrate? It's because your ocular micrometers in itself, no, the lines there, they are arbitrary. They don't have a specific measurement. All right. So it's not standardized for each objective. That is why we need to calibrate per objective that we use and per microscope that we use. Okay. So if this microscope, this is the calibration of it. For the next microscope, it's different. Okay. We need to calibrate. All right. And again, why is it important? It's because again, size matters in our parasitology class. Okay. Maybe some aspects dili mo matter ang size, but for our class, mo matter ang size. Actually, size matters good. Charot. Okay. All right. Ayan. So I hope, dears, you understood our lesson, no? Again, if you have any questions, feel free to chat in our group chat. Don't be shy, no? And again, we'll practice in solving and calibrating your micrometer, ocular micrometer. Okay. All right. So thank you, dears, for listening, and I hope you learned something today. And yeah, thank you again. Have a great day, guys, dears, and keep safe.